Hi, we are going to look at chapter 20. We're going to start, of course, with 20.1. This is talking about the interstellar medium. And so, what is interstellar medium? Well, it is the gas and dust between stars. 99% gas, 1% dust. We'll talk about the gas specifically in section 2 and the dust in section 3. Couple of things to remember here is that in the interstellar medium, 99% of it is gas, 1% dust, and between the stars, it's far more of a vacuum than anything we can do on Earth. In a cubic centimeter, this big cube, um, between the stars, we're looking at one atom. In this room, there's probably 10 to the 19 atoms in that space. And then the dust is solid. And so that is the majority of, the important information out of section 1. It does talk in this very last gray box, astronomy basics, about how we name nebula, and most of them have names like NGC 4327. But a few of them that we can actually see in a small telescope have names that look like what someone thought it resembled. Crab Nebula is a very famous one, and to me it does not look anything like a crab, but okay. Anyway, section 2, we start talking about the actual gas, and there's several different types of gas. So first thing to remember, hydrogen, those Balmer lines that Annie Jump Cannon used to classify the stars, the strongest Balmer line is red. And so when we see pictures that are true color and there is red in them, that tells us that there is a lot of hydrogen and that hydrogen is possibly ionized. So, types of gas. There's ionized hydrogen, and this is called H2 with Roman numeral 2. People who work in spectroscopy or, chemistry, neutral means is H1 would be neutral, H2 would be ionized. And so we talk about H2 gases. H2 gases, gas clouds, are, really hot, 10,000 Kelvin. So these are usually in regions very close to stars. And it's hot enough that the electron has been stripped off of the hydrogen. Next type of gas out there is neutral hydrogen. So this would be H1, except nobody calls it that. They simply call it neutral hydrogen. So neutral hydrogen does not emit light. It does not really absorb light. It does not combine with anything that we can see, but it does absorb some of the other elements that will combine with neutral hydrogen absorb visible light. So where we have neutral hydrogen clouds, we will, we see this here in 20.4. The light from the star, and it passes through the cloud and gains extra absorption lines because there's a dust cloud there, an interstellar, neutral hydrogen. So we can see where those exist. We're going to talk more next week about 21 centimeter absorption and how we use that to look at the arms of the galaxy. So that actually won't be next week. That'll be in like 3 weeks. But the formation of the 21 centimeter line happens when the electron in a hydrogen orbits closest to the nucleus, and the electron flips over. And when it does that, the atom gains or loses an amount of energy that moves in a 21 centimeter wave. And so we see those waves in 21 centimeter, and tells us a lot. Interstellar hot gas. Actually, I'm going to stop this video so that it doesn't get too long and start a new one.